Hi everyone, please turn to 8.1 in your notes. Let's see here. Hopefully that's okay. Okay, so perfect squares and square roots. On the first page of the notes, I've created a chart where I'm going to put all the perfect squares from numbers 1 to 25 just for you to reference. 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Hopefully you have all those memorized. 13 squared is 169, 14 squared is 196. 15 squared is 225, 16 squared, 256, 17 squared, 289, 324, 361, 400, 441, 484, 529, 576, and 625. Okay, so example number 1, find all square roots of 49. The positive negative square root of 49 is going to be 7 or negative 7. And the reason it's both positive and negative is because if you think about it, 7 times 7 is 49, and negative 7 times negative 7 is also 49. Okay. Let's go all the way up to the Pythagorean theorem and then we'll stop. Okay, example number 2. Find each square root. The sign of each square root signifies whether the root represents the positive or negative square root of the number. Okay, so 0.81, this is going to give you 0.09. 1024. Something you could do is use your calculator. Sorry, the glare. 32. Root 4 over 9 is the same thing as root 4 over root 9, which is 2 over 3. Likewise, this would be negative 4 over 7, not 4 over 9. Okay. All right, example number 3 says find the square of each radical expression. So what they're looking for is what happens if you square this. In this case, the squared and the square root cancel out, and I'm left with p squared plus 1. Over here, if I square this, the negative times a negative becomes a positive, and the root 29 just becomes regular 29. Okay, irrational square roots. If a is a positive real number that is not a perfect square, then the square root of a is irrational. If square roots that are not real, if a is a negative real number, then the square root of a is not a real number. Okay, so for example number 4, we're going to use that information to tell whether each square root is rational, irrational, or not a real number. The square root of 17, 17 is not a perfect square, so this is irrational. The square root of 64 is just 8, so this is rational. And this one is negative. When you have a negative inside a square root, it is not a real number. Ah, bad. Okay. Example number 5. Find a decimal approximation for each square root. Round answers to the nearest hundredth. Okay, so the square root of 11, I'm going to go second root 11. I'm going to get this. So this is approximately 3.317. It says the nearest thousand, so that's 3 decimal places. If you do that same thing for each of these, you're going to get 6.245 and negative 27.203. Okay, and that's all the notes for this section. Thank you so much for watching.